Basically, a protocol means the way how you are going to send some data from one place to another. So there should be a set of rules how you should send. Now we started looking at one of the protocol called Pure Aloha. In that I told you, when you have this protocol, that means if you are abide by these set of rules, what are the rules? Whenever you can send in Aloha, you can send anytime. So that's why here we have 4 stations and then freely they can send. Now what will happen when you try to send all the 4 stations at the same time? There will be collisions. එකම වෙලාවේ signal අපි આવොත් ඒවා collision එකට ගැටෙන්න පුළුවන්. So it will destroy these the frames that we are sending, right? So there's an improvement in the next version which we call slotted Aloha. Slotted Aloha you can't send anytime you want. Here you can send anytime you want, but here you can't send anytime you want. You have a time slots. So there are time slots divide, and whenever there's a time slot, let's say every 10 minutes, sorry, every 10 seconds, you can send. So you have to wait. You send something, wait for 10 seconds, you send some other frame, you know, likewise. So what will happen then? The collisions are minimal, right? You see, still there are some collisions, but this time full collisions. Now here there could be partial collisions. Partial collision කියලා කියන්නේ මේකේ එක කොටසක් විතරයි damage වෙන්න පුළුවන්. මේකෙදි සම්පූර්ණ මොකද ඒ slot එකේදීම තමයි අපි data එක යවන්නේ. So that's the difference between a pure Aloha and slotted Aloha. Then we want to also discuss the Ethernet protocol, right? How the Ethernet, and that's the last one we need to discuss under, you know, protocols. So there's Aloha, then we have a slotted Aloha. So in Ethernet, it's actually improvement of, you know, Aloha and slotted Aloha. So it allows what we call multiple access of common shared media, right? So let's see what this means, how Ethernet, you know, protocol works, right? Right. So these are the steps we will take down, but before that, right? So how in Ethernet this will work when it comes to transmission media. Now, when you say transmission media, so we assume that we are in a network and we are trying to send the data. Now, when two devices transmit the data to the transmission media at the same time, we know signal collide, right? Okay. So Ethernet protocol use what we call CSMA-CD. CSMA-CD means carrier sense multiple access collision detectors. It's a technology which prevents this data collisions. So how to say that how to work this? So before entering signal anything to media, it will check whether there are already transmitting data in the medium. Now we said earlier, like there are 4 stations. So we are checking first, right? Whether any of the other stations are using this. So if no transmission is there, then you transmit, right? You transmit. Now there should be still you know, problems because 2 stations can send the data at the same time, right? Right. If there's no collision happens, right, you continually transfer the data. Let's say there's a collision, then it's data, right, transmission, right? So if there's a collision, then you wait for some time, right? It starts again. So this one is better than the slotted Aloha, right? So what happened in Ethernet protocol, I told you, it will check the medium. First of all, it checks If there are any transmission, you are not going to do anything. If there are no transmission, then you start transmitting it. Let's say you have another station, then there will be a collision. If there's a collision, then wait for some time and then you resend the again, right? That's how it will work in Ethernet protocol. Right. Now let's take down Nimasha and then I will explain one more time. So let's take down, we said Ethernet protocol, and what we said was in Ethernet protocol, first checks the medium. If the medium is not used by any device, it sends the data frame, right? It's the same, sends the data frame, right? But let's say, right, however, if two devices, if two devices transmit data simultaneously, it will cause collision. If no collision, then data will be transmitted. When there's a collision, it stops the transmission. Right now, here is what I'm trying to say. Now, first of all, before you put data into the medium, it will be a wire, right? So before you put the data into wire, you check whether it's free. The lines should be free, right? Now here, all the machines, you are using one line. I mean, if I go to here, now you are trying to send from here to here. This is the medium, like if you put a data here and at the same time, if somebody else put the data here, they can collide each other, right? So because of that, you check the medium whether this is free. This is like a, you can think like a pipe and you are trying to send water, right? So you check whether there are existing water there. Likewise, you check whether there are any messages going here and there in the medium. So if not, only you are going to putting it. But when you put it, right? So what happens is two stations can do the same thing because both of them can check the medium and they wait for free and they are trying to send the same time. So it could happen. If there's a collision, then what will happen? It will stop and then wait for some time and then starts again. Now, in earlier days, in this Aloha, what happened? As soon as you have data, you send. You don't check. But here, it's different. What it is, you have a time slot, and in the time slot, you are sending. Now, Ethernet is a more intelligent. So it will first check whether medium is free. If it is free only, it will send. If there's a collision, then wait for some time and send it again. So this is much better than both the Aloha and slotted Aloha. then it waits for some time and starts again, right, to send the data. Right now, if I go through this Ethernet protocol, how it works, it will first check the medium. If it is not used by any other device, it sends the data. If two devices transmit simultaneously, it could happen because both of them are waiting and then they can send. Then there's a collision. If no collision, you transmit the data. But if there's a collision, then you stop the transmission, right? So then you wait for some time and starts again to send the data. එහෙනම් මේ ඉදනෙට් ප්‍රොටෝකෝල් එකේදී වෙන දේ තමයි ඉස්සලා මීඩියම් එක ෆ්‍රීද කියලා බැලුවා. කළා ඩේටා එක රිලීස් කරා. හැබැයි එකම වෙලාවෙ දෙන්නෙක් රිලීස් කරොත් කොලයිඩ් වෙන්න පුළුවන්. කොලිෂන් එකක් වුණොත් ඔයා නවතිනවා. කළා ටික වෙලාවක ආයෙ try කරනවා. කොලිෂන් එකක් නැත්තම් data ටික නවතිනවා. So that's only what you need to remember. Right. Now the next one is I would like to discuss transmission methods. Right, to finish this part. Himanshu පුතේ මේක ලියාගෙන ඉවරද? Are you done with this?
Oh, sorry.
Yeah, okay. So let's take down we have to discuss broadcast and unicast messages. Now this is transmission. Transmission means you are sending some data from one place to another, right? So one device to another, right? So unicast, the term unicast means, right, you are going to send from one point to another point, or one device to another device. So which means you have one sender and one receiver. So that's we call unicast, right? So if you have only, data transmission happens in only two parties. But when you say multicast, so multicast means you are sending data from one to multiple devices. We call multicasting. The last one we call is broadcasting. Broadcast means you are going to send it to all the devices in the network. Now, for example, if you have television and radio networks, it will we call broadcasting. So they will send to everywhere, right? So this is called data transmission modes. So let's take down this data transmission mode. The next one. Transmission modes. So under that, the first one I'm going to discuss is unicast. Unicast. Information is sent from one device to another in a network. This is called unicast. So this is useful when there is one sender and one receiver. අර මං ඔයාලට දුන්න එක්ස්ට්‍රා එක තියෙන පුතේ මං. So in unicast, as I told you, we will have one sender and one receiver. So let's draw a small figure for this. So I'm going to represent a sender like this. And let's say we have multiple receivers. So we will, let's say we have 4 receivers. Right? So let's assume that we have 4 receivers like this. So unicast means we have only data sending into only one, like this. So this is called unicast. The second one, multicast. Right, in multicast, information sent from one or more points to set of other points. So it could be even more points, but for the time being, let's say going from one device to many devices, but not all devices. Right? So I'm going to make use of the same diagram. So here we have right. We can say information is sent from one device to a set of other devices in a network. So we can draw the same thing, but this time I can draw another line, right? So maybe it'll try to send it to this one as well, but not everyone. So this is called multicast. Third one, broadcast. Transmission. Information is sent from, let's say, one device to all other devices. So in this particular case, what should happen? So the one device, it should send from one to all other. All other. Right? So this is called broadcast. I hope you got the idea of this. Right. Now with that one, we have finished 6.6, right? A one-to-all communication between one source to all host on a network is classified as, what was the answer? You are sending from one to all. Means, now what is unicast mean? Unicast mean one to one, isn't it? Multiclass, one to many. And broadcast means then one to, yes, all hosts, right? Okay, right. So let's start with the next one. So this is 6.7. Uh, in 6.7, we are going to discuss how multiple networks are connected together to form internet. So we have not discussed this idea in earlier. Um, what we discuss is internet is networks of networks. That's what we have learned so far. Now we are going to look at one step ahead just to see how internet is constructed, right? So we are going to talk about what we call the gateway devices, right? And then use of MAC protocol, we call independent addressing scheme, and how IP addresses, use it there. Right? And then we are going to discuss what we call subnet marks. I will come to that one. And then the techniques we use, how you may dynamically assign IP addresses. We know one thing, whenever we want to have a computer in the internet, we have a unique address, which we call IP address. So we discuss how IP addresses are assigned, right? And then another thing that we are going to discuss, how you are going to find a path going from one place to another place in a network. So this is the basically what we are going to discuss in section 6.7, right? So basically we need a device to connect networks together. Now so far we know in a network we have different devices. We discuss hubs, switches and routers. They are within the network. But when you want to connect a network to a network, we need a device which we call gateway, and we are going to start with that, right? And then we are going to look at like MAC addresses and LAN technology, how these IP addresses are used. So let's start with gateway, right? So let's take down a device, or simply we will say gateway, right? So this is 6.7. Under 6.7, what we are going to discuss, right? How the multiple networks are interconnected to form the internet, right? So simply we start with a new device, right? So network gateway is the device which is used to connect a network, used to connect two networks together so that So gateway is the device which is used to connect two networks together so that one network can communicate with the other network, right? So that's we call gateway. So let me give you a simple image just to illustrate this idea. So in this one, what you see is one side you have star network or star topology network, and then the other side we have bus network, right? This is star network and this is bus network. So this is network one, this is network two. Now, especially when you have two different networks like this, to communicate each other, we need a gateway. So let's draw this. So we are right now discussing IP addresses. And I told you there are two versions, IP version 4 and IP version 6. So IP version 4 is 32 bits, and that's what we are going to discuss under IP addresses. And IP version 4, you have 120. So formats are given here, right? So let's start with the IPv4 addresses. And what you need to remember is there are four 8-bit numbers separated by dots, right? And each number, you can say each number eight bits. We call it octlet, octels. Octet. octet. Octet, we call it. So this is given, that's why I gave you. Right? So we say IP address. So the each of the values in the IP address should goes from 0 to 255. Right? So we can say, right? So we can have different IP addresses. So a valid number should be within 0 to 255. So remember, this is very, very important. One of the questions you use to get about the IP addresses. Right. Right. Now I told you earlier that IP address, you have two parts. You have a network part and host part. So I will explain what those are, right? We need to take down this. So first of all, we need to learn there are 5 subclasses. Right? So we will write down the 32-bit IP address. That means IP version 4 is divided into 5 subclasses as class A, class B, class C, class D, class E. Right. So in your level, we are going to talk about only 3 classes. That means class A, class B, and class C. Each of these classes has a valid range of IP addresses. Right. Now we discuss IP address. You have 32 bits. 32 bits means you have 8 bits. Now we are going to say that, okay, there are 5 different classes. Although we have 5 different classes, so what we are going to discuss more in detail is 3 classes, class A, class B, class C. In each of these, you have 2 parts, network and host. Now, next one, we are going to look at how we can separate out what are the valid ranges. So in the exam also, we need to know these things. So what are the valid ranges for class A, class B, class C, and so on, right? The IP address is divided into 2 parts as network ID and host ID. Right? So let me give you an example image which represent this one. So this is how it will work. Now we know from beginning the address has 4 bytes. 8-bit means 4 bytes, right? So class A, it will use 1 byte for network, 3 bytes for the host. Class B, it uses 8 bytes for the net and 8 for the host. Class C uses 3 bytes for the net and 1 byte for the host. And class D and class D are they are not really using. Class D is reserved for multicast, and class C for some experimental purposes, what they say. So these two are not, we are not going to discuss in detail. So let's talk about the class A addresses. So in class A, right, uh, class A contains a large number of hosts. So we know from here the network ID is 8 bits and the host ID is 24 bits, right? So how many ideas we are going to get? So the network ID is 8 bits and the host is 24 bits. That we already know from the beginning. Right? Another one you need to remember, the first bit of the class A is always 0. The first bit, that means most significant bit, it will be 0, right? So remember, we said 8 bits for the network ID, and then we have 24 bit. The first bit is 0. So that means you have 7 bits remaining, right? 7 bits remaining. 7 bits remaining. Connect with it, right? So there is 7 bits in the first octet. Remember, that means first 8 bits, right? We said octet. First one is 0. The remaining there are 7 bits. Determines network ID. Now earlier we said we have 8 bits. But since this class A, we are going to say the first one is 0. Then we have remaining with 7 bits. Right? Understood? The 24 bits determines right? That is the host, right? So 24 bits determines hosts in any network. Then another thing, when we need, right? When we create the networks, we need what you call subnet marks, right? So what is a subnet marks is usually it will be 32 number, and this will set hospice to 0 and will set network bits to 1, right? That's a subnet mask, right? So I will explain this, right? I will put this, right? Here we have um, we will say the subnet mask. I will explain what mask is. A 32-bit number where network bits are set to, what is it we said? Network bits are set to 1 and all the hosts are set to 0, right? That's what I said. So we say network bits to 1, 1, and host bits are set to 0. Right now, since now we say subnet mask is a 32-bit number like in earlier, all the networks are set to 1. So what I said earlier is we have 8 bits for network, right? 8 bits for network. So that means we have 1, 1, 1, 4, 5, 6, 7, 8. Right? Then all the others are 0. So we have 8, right? Yes. Right. So that means 255.0.0.0 is the subnet marks for class A. Here we will say default, default subnet mask. That's the proper word for that. Right. So we will discuss later on how we are going to make use this subnetting. For the time being, we are going to take down this. So we talk about subnet. So now a few things we discuss. Class A, you have a large number of hosts. The first bit is 0, right? And then you can have large number of hosts. So how many? It's 2 to the power 24, that is 16 million, right? So we can say that the number of hosts, right? Now we know this. So we can say the range of IP addresses for class E is 10.0.0 to 126.0.0.0. So this you need to remember the range of IP addresses. The number of hosts are 2 to the power 24 bits we have. That is 1677721. This is 2 to the power 24. It's a little bit more than 24 million. Sorry, 16 million. 16 million. Right. So that's all you need to remember about class A. To finish this one, let me improve this. So how this will work. So this is how the class A we have class A network. So like this. Now, if you ask me why we start with 1000, not 0000, it is because it's a special one. 0.0.0.0 is a special address. So that's why start with 1. And 127 also is special at so otherwise you know that when you have 8 bits, right? Now first bit is 0, then the remaining is the we have to use for the network. So that means altogether we can 128, that means 0 to 127. But 127 is a special, so that's why it goes from 126. So what you need to remember is if IP address starts with 1 up to 126, forget about the remaining numbers. We can say that the IP address is in class A. Right, now let's move on to class B. Like in earlier, right, we discussed class B here. So class B uses 2 bytes, that means 16 bits. Here also we have 16 bits. Okay, so let's start. So class B. The first thing, like in previous case, in this particular case, there is no huge, but you can say uh, class B addresses, usually we have medium size to large size network. So we can say class B addresses are assigned to medium size to large sized networks. So now we know the network ID. ID is 16 bits, whereas the host ID is 16 bits. Remember? So that we have discussed earlier. And remember the first 2 bits. Now in class A, I told you the very first bit is 0, right? So here the first 2 bits is always 1, 0. The first 2 bits is always 1, 0. Okay, remember this. So we have 1, 0. So which means, right, like here, we have to use 2 bits, but we have 16 bits. That means we have to use 14 bits, right? 14 bits are there. We have to use 14 bits. So we can say the first 2 bits is always 1, 0, like in previous case. So which means 14 bits. We can say 14 bits. How do you get 14 bits? 16 minus 2, right? Because in network we have 16 bits. The first 2 bits is always 1, 0. So the remaining will decide this, right? So you have 16 bits. Are used to determine network ID. Then 16 bits the second 16 bits are used to determine host ID. The default subnet mask is, what do you mean by subnet mask? The network is always 1 and the host is 0, right? So that means we will go down. We will have the default mask for class B is, we can say what? 1, 1, 1, 1. Right, then it will be 0. So that means 255, 255, 0.0, right? So that's a mask. So how many hosts are there? Yes, the range of addresses for B we can write now. The range of IP addresses for class B is, this you need to remember. Yes, it's 128.0.0.0 to 191.255.0.0. So remember this. So this is the range of IP addresses for class B. The number of hosts are 2 to the power 16, that is 65,534. So this is 2 to the power 16. If you ask me why 16, because we have 16 for network and 16 for hosts. That's how we are going to make the separation. Actually, in here, we have to subtract 2. So otherwise, 2 to the power 16 means 65,536. We have to reduce 2 to remove 0, 0, 0, 0, as well as 2555. So they are special ones. Right. So here also, the earlier also, I think you better put this is should be 224 subtract 2. That's how we get 214. Otherwise, it will get 216. Right. So in this particular case, this is this. Now we can draw the class B. So here is how we have class B is. Right.